Inspecting receptacles. The InterNACHI Home Inspection Standards of Practice requires that the inspector inspect a representative number of receptacles, including those deemed to be GFCI and AFCI protected. It's a good idea to check every receptacle that can be physically accessed and that does not have something plugged into it, as well as every GFCI or AFCI protected circuit. Let's learn a bit about how receptacles should be correctly wired. A three-prong receptacle has the following characteristics. The short, small slot opening is the hot or ungrounded supply. The long, large slot opening is the neutral or grounded return. The round hole opening is the grounding conductor. This is very important if the receptacle has reversed polarity, hot and neutral wires switched, because then things like lamp holder collars may become live and pose an electrocution hazard. In an older house, it is common to find three-prong receptacles with no ground, or worse, receptacles with a false or bootleg ground where the grounding terminal has been improperly connected to the neutral. Circuit testers. There are many different types of circuit testers available, starting with very basic continuity testers, which cost a few dollars, up to full function testers, which cost several $100s. The differences between the various models are what they are able to test for and how they display the result. It is a good idea for an inspector to have and use a receptacle tester with a GFCI and/or AFCI testing feature. However, the best way to test a GFCI or AFCI is by pressing the test button on the device itself. The functionality of some common testers can indicate open ground, open neutral, open hot, hot ground reversed, hot neutral reversed, normal, GFCI trip, bad or high resistance ground, AFCIs for proper operation, GFCIs for proper operation, shared neutrals, and correct wiring. False grounds, sometimes referred to as bootleg grounds. False grounds occur when the grounding terminal on the receptacle has been improperly connected to the neutral. Most testers will not be able to read this condition, as the grounds and neutrals are correctly terminated together at the panel anyway. The inspector should be suspicious of older style wiring in the panel that tests like a grounded circuit at the receptacles. It is common to find an old home with two wire conductors upgraded to three-prong outlets where the ground has been faked. This can lead to very dangerous conditions downstream of the receptacle with the improper connection, especially should there be any wiring or appliance failure. Voltage drop. Some inspectors are now starting to check voltage drop along conductors. This falls well outside of the standards of practice, but with electrical components becoming ever more sensitive to voltage fluctuations, many more inspectors will start to check for this. Also, the voltage drop can be indicative of too many outlets on a circuit, poor connections, or undersized conductors on long wiring runs, all of which could lead to overheating and failures. The National Electrical Code recommends that voltage should not drop more than 3% on branch circuits and a 5% overall drop, including the service itself. Ungrounded two-prong receptacles, often found by an inspector in an older home that are connected to two-wire cables, do not have ground wires, which protect people and electrical devices in case of a fault. It is possible to retrofit a new three-prong or GFCI receptacle into the same receptacle box without any rewiring, as long as the box itself is grounded. Metal boxes attached to armored or BX cable, which is a type of wiring commonly found in old homes, are typically found to be properly grounded. The armored or BX cable's flexible metal jacket serves the same purpose as a dedicated ground wire. If the box is not grounded, a GFCI can be installed, or an electrician can be hired to fix the wiring. Simply replacing an older two-prong outlet with a three-prong outlet can be hazardous because the receptacle will appear to be functional with a ground, but in fact, there isn't one. If someone were to plug a faulty three-prong device into that fake grounded receptacle, a shock hazard is very likely. Electricity moving through the device casing would create an energized surface from which a person could be electrocuted. Another problem with replacing ungrounded two-prong receptacles with three-prong receptacles is in relation to surge protection devices, which rely on solid ground to route any transient activity. The ungrounded receptacle would not be able to protect the device from a surge. It is permissible to replace a two-prong ungrounded outlet with a three-prong GFCI outlet, but it must be labeled as GFCI protected outlet, no equipment ground. Even though there is not a grounding conductor, there is still some protection against shock provided by the GFCI. If an inspector has doubts as to what is being inspected, a qualified electrician should be consulted. Inspection recommendations. The home inspector should check the following conditions on a representative number of receptacles: no power present, no ground, open neutral, reversed polarity, hot and neutral, and reversed ground and hot. The inspector may also choose to invest in equipment to enable them to report on low resistance grounds, bootleg grounds, true voltage, and voltage drop.